I thought the bridge piers would be built directly from underwater, but it turns out that a gap was first created in the water flow. It sounds impossible, but you cleverly drove a ring of closely spaced wooden piles into the riverbed to create a temporary cofferdam. Then you pumped out the water inside the cofferdam, creating a dry open space suitable for construction. To make the wooden piles stable, you drove the piles deep into the riverbed until they reached the hard salt layer. However, there was still a problem. Water would leak between the gaps in the wood, so you built a second cofferdam on the outside. The layer between the two cofferdams was filled with mud and mortar. After the mortar dried and solidified, it would no longer leak. At this moment, the water flow outside exerts an inward squeezing force, while the water inside counteracts this force. However, as the water inside is pumped out, the cofferdam will collapse instantly. Therefore, you need to add a few pieces of wood to support the cofferdam. Then pump out the water and clear out the silt inside. Fill the foundation with gravel mortar. After it dries and hardens, you can build the bridge piers on top. Fill the gaps between the stones of the bridge piers with lime mortar. This will solidify into a solid whole. Then dismantle the temporary cofferdam. When the tide comes in, use boats to carry the stone beams. Transported between the bridge piers, as the water level drops, the stone beams can be placed stably. This is the floating beam method. A smooth stone slab bridge surface is laid on the stone beams. A row of railings is built on both sides to prevent pedestrians from falling. Then a long corridor is built on the bridge to shelter the bridge and passers-by from wind and rain. So you have invented the covered bridge. But too many bridge piers will obstruct the passage of boats. So when building the second covered bridge, you first use wood to build a frame in the river. On the frame, a large arch spanning both banks is built with stone bricks, and all the stone bricks must be joined together perfectly. After the supporting wooden frame is removed, the arch can stand firmly on its own and support the heavy bridge body above. However, during high tide, the sides of the bridge will block the water flow, so several arches need to be dug to drain the floodwater. Then you invented the single arch covered bridge, which greatly facilitates the passage of boats. 3. However, in wide sections of the river, the construction of a single arch covered bridge is very difficult. If the arch is too high, it will be inconvenient for passage. If the arch is too low, it will reduce the load-bearing capacity. Therefore, you cleverly combined the construction methods of the previous two bridges and built the piers and arch together. It seems to reduce the span, but in fact, the load-bearing capacity is very strong. And with such excellent piers and arches, the main body of the bridge and the buildings on it were naturally made magnificent and imposing by you. At the same time, you did not forget to reserve 2 flood discharge arches on the bridge and build sloping water dividing channels on the water receiving surfaces of the piers so that the water flows smoothly to both sides, reducing the impact on the piers. Finally, you carefully carved 2 mythical beasts to suppress water and protect the bridge. So congratulations for inventing the Anchuan covered bridge. It is located in Chengdu, Sichuan. Although it has been destroyed and rebuilt, it can be traced back to the Yuan dynasty. It is one of the 4 Chinese bridges that Marco Polo found most impressive.